Okay, this is the P3 paper from October 2022. It's question number 8. We can see part of this work is trig addition formulae. We're going to be expressing things A sine x plus B cos x in the format R sine x minus alpha. And then once we've done that, we're going to be working out maximums and minimums using that work. And then afterwards, we're going to be looking at combining transformations. So let's have a look at the first part. Very straightforward. We should be absolutely on top of doing these types of questions where we've got a question in the format. What have we got? We've got 8 sine x minus 15 cos x, and what we need to do is to rewrite that in the form R sine x minus alpha. Well, hopefully you've done lots of these. This is 8 sine x minus 15 cos x equals sine A minus B is sine A cos B minus cos A sine B. So this means that on the right hand side we can have R sine x cos alpha minus R cos x sine alpha. Now as soon as we do that, what we're looking at is what's multiplied by sine there, 8, what's multiplied by sine there, R cos alpha. So we're going to equate the coefficients. So if we say that, equate the coefficients, we're going to get that R cos alpha equals 8, and similarly R sine alpha equals 15. R sine alpha is what's times by cos there, and R sine alpha is what's times by cos on that side. It's minus 15 and minus, but those two things obviously cancel out. So we're used to doing these. We label the equations 1 and 2, and then the way to tidy those two up is if we do 2 divided by 1, the r's will cancel and we get sine over cos, and sine over cos is equal to tan. So we're going to get tan alpha is equal to 15 over 18. So remembering, or just checking if you haven't already, then what do we want? R is going to be an exact value and alpha is going to be in radians to 4 sig fig. So make sure your calculator's set as radians. Tan to the minus 1 of 15 over 18 works out to be 1.081. When we're working out R then, again, as I say, you should have done lots of these. It's the square root of this squared plus this squared, 8 squared plus 15 squared. And quite often, like with this one, these choose numbers that almost you should recognise. I know the 8, 15, 17, it's going to be 17, is one of the right angle triangles that I remember, alongside 3, 4, 5 and 5, 12, 13. But you can just work it out. It works out to be equal to 17. So then R is equal to, write it in the format that we wanted. 8, not R is equal to, what am I doing? 8 sine x minus 15 cos x is equal to R sine x minus alpha, so 17 sine x minus 1.081. So we've now written it in the format that we wanted to have. Absolutely fantastic. Okay, on to part B here then. So part B now is talking about, B part 1 at least, is talking about fx being this function, which is 15 all over. And then what have we got? We've got 41 plus 16 sine x minus 30 cos x. Well, as I say, I'm used to doing these questions. What I'm doing is looking at that part there and comparing that to what we had in our question, our 8 sine x minus 15 cos x. It's not a complicated little bit of rearranging then to say this is 15 over 41 plus. This is just 2 lots of what we had in the original question, minus 15 cos x. So now, what am I asked to do? I'm trying to find the minimum value for fx. If I'm trying to find the minimum value for fx, then I want this denominator to be as big as possible. I want to divide by the biggest number. That'll give me my smallest, in this case, my minimum value for fx. So if that's the case, then fx is going to be equal to 15 over 41 plus 2 lots of 17 sine x minus 1.081. Let's write it down like that first of all. Try to do this, but I'll just move this over a bit. 15 over that, but then as I just said, what we want is this to be as big as possible, and the biggest possible value that can be is 17, is our R. So for minimum fx, we're going to get 15 over 41 plus, and the biggest value, as I say, inside here is going to be 17, so we're going to get 2 lots of 17 there. So that works out to be 15 over 41 plus 34, and that works out to be a fifth once we tidy up all the numbers there. Part 2 says, when does that occur? Well, that occurs when the sine part, sine x minus 1.081, just think about what sine looks like. Okay, sine does that, doesn't it? Just really, really quickly. The maximum value of 1 occurs when sine, or rather when the angle is equal to 90 degrees, is equal to pi over 2. So it occurs when sine x is equal to 1, or in other words, when x minus 1.081 is equal to pi over 2. Yeah, it also occurs here, and it would also occur here, but that's why they ask for the first value for which that occurs. I'm not going to leave that my answer, don't need that. So x is going to be equal to whatever pi over 2 plus 1.081 is, and that works out to be 2.65. And again, if we go back and just check, I've done that in radians, and I've done it to 3 significant figures or 2 decimal places. It hasn't said anything about what it wanted for that one. Part C now says state the y coordinate of the minimum points if we do this as a transformation. So if we do that as a transformation, y equals, let's just say what we're doing here for part C. If y equals 2 fx minus 5, what happens if we do that transformation to our value of a fifth here? That's the y value. So the new y minimum would be 2 lots of a fifth minus 5, and then just work that out. That actually works out to be minus 23 over 5. So if we did this transformation, we'd be doing that transformation to the minimum point as well. So the new minimum point then would be equal to that one. D, very similar, but just a slight difference here. For part D, just go back and, sorry, I'll give you time just to have a look at those if you haven't. We were finding the y coordinate of the minimum point when we've done this. This now says the smallest value of x at which a maximum point occurs. And you might think, oh, I'm doing a different function. You're not, or you're not doing anything particularly different. When we do minus f2x, the graph is going to be flipped upside down. And so let's just write it down before we start talking about it. Y is equal to minus f2x. So I'm still interested in the minimum point for the last one, if it looked like that, which will flip over to be the maximum point when I do minus f to it. And then the fact that it's 2x means, whereas I had my x value, and it's the x value, not the y value this time, so they're really sort of jumping about here, we're going to get that 2x is equal to 2.65. I'm going to use the entire number on the calculator, but 2x is equal to 2.65. So x works out to be that divided by 2, and that works out to be 1.33 if I do it to 2 decimal places, which is what I've decided to do for BCD. Okay, hopefully that makes sense.